Greetings everybody, my name is Shubhkarman Singh and in this video I'm going to tell you about my summer internship that I carried out at Indian Institute of Technology, Ropar. I did this internship under the guidance of Dr. Sudarshan Iyengar, Assistant Professor at IIT Ropar. The name of my project is Weighted Centrality Measures. So the first thing that we should know is what do you mean by centrality measures. Now there are different kind of centrality measures. We actually use centrality measures in day-to-day life, and to give you a blink, let me show you one thing. So this is a plot of Facebook. So as in this plot, we can see different number of nodes. We can also see number of links. The links between any two edges correspond to the, like in a Facebook network, it corresponds to the link. Like if node A is a friend of node B, so we'll put a link. Now if we want to examine this network in detail, so I've run a script using the dataset available on Snap Stanford website. So if we zoom on this, here is some problem. Okay. So when we zoom on it, we can see that there are a lot of edges, a lot of nodes, and there is a formation of clusters. So in this scenario, we can see that each node is connected to another node. So if a property of the node is judged by the number of links it is connected to, that is the direct links. So in that case, the centrality which corresponds to this scenario is the degree centrality. So degree centrality is the measure that ranks the importance of a node according to its links with the neighbors. There are some other centralities as well, such as eigenvector centrality. Eigenvector centrality ranks the importance of a node based on the importance of its neighbors. So if a node has a very strong, a very popular neighbor, then the importance of that node would be high as compared to any other node that is even having more links as compared to that node. So a very successful variant of eigenvector centrality is used in Google page ranking. So the centrality measures define. So the centrality measures have been proved to be very successful in many domains, such as economy and computer science. Now, there are certain more centrality measures, such as the closeness centrality, which tell us how close I am. If there are two nodes, if A node is close to B, then its closeness centrality will be more. If it is more close to C, then it would be accordingly. So all these centralities tell the importance of a node. So that is the basis that why I choose this project. Now you can see that in these scenarios, the importance of a node is the utmost. So to find the importance of a node, there are certain measures. We need certain measures. We have to club the traditional measures like the degree betweenness, the eigenvector, and the closeness. So we have to take all these measures and build certain measures so that we could find the most important node. For instance, in this case, in this scenario, we took the road network of India. Now we can see that there are different kinds of nodes. Now there are around 600 nodes and around 1500 edges. So we plotted this graph using Python. So the most difficulty while actually implementing was that we have to be perfect in Python. So that this is a graph of railway network of India. So there are approximately 3000 nodes and 6000 edges. So this was all the graphs that we actually worked on during our summer internship. Now this is also another type of graph, that is, you can see this is a graph of the state Bihar. So we have plotted all these nodes. So basically what we did was we proposed some measures, some weighted measures that calculated a maintenance center. For example, if you consider a power grid network. So in a power grid network there are different kinds of nodes. Each node corresponds to a power grid. So the importance of a node is judged by the possibility of that node lying between any two nodes. For example, if there are three nodes A, B and C, and if we want to and the electricity passes from A to B. So if C lies in the path of A to B, or the C lies in the maximum number of shortest paths from A to B, so in that case C would be the most central, most important thing. So if C is damaged, so thereby the electricity won't flow from A to B. So in this case it would cause a loss. So there is a need of a maintenance center. So this was a problem, finding a correct position. There are multiple positions. We can always put a maintenance center. We can always put 1000 maintenance centers, but we have to find the correct position of a maintenance center. And for that, we used some weighted centrality measures and computed the maintenance center in all these networks. Like we computed it in a road network and in a railway network. So in all these networks, we computed the maintenance center and conclude that our methods are better than the previous approach, the traditional approach. Like if we only implemented all these graphs using the traditional measures, then we would also get a ranking. But the ranking produced from our measures is far better than the traditional measures. And moreover, very less has been accomplished in this field. So this was an opportunity for me to work on this project. So hopefully we have completed this project and also written a research paper on it, so for which we are actually finding good conferences to publish on. So that was the brief introduction of my project. So thank you.